had like, you know, very real impact on people's lives. And so like that's kind of an extreme example, but a more mundane example might be, you know, if you are serving recommendations on an e-commerce site, and the recommendations just like aren't good enough, or you know, in a particular subset of users or subset of products, the recommendations are just like really poor, you know, that has a real impact on that business in terms of like lost revenue. And so you want to go back and be able to know exactly, you know, again, did this model need more particular training examples for that particular product or for that particular kind of user profile that you were recommending to. And so this kind of brings us to the reproducibility gap that we see in machine learning and deep learning today. You know, ML and deep learning is, you know, relatively like young fields. I mean, assuming we're not going back to the 60s and discussions of AI, but in terms of like, you know, being like widely used and being deployed in the real world, it's a young field. And so like there's this catch up that we need to do in terms of like ensuring that we can reproduce our results. And so there's a bunch of things that we need to address here. And so training data is like the kind of one of the most obvious ones, and the one that, you know, a lot of people would cite when pointing to like large tech companies, for example. But if you can't train your models on the same data that others have trained on, you can't exactly reproduce their results. And I'm sure like that's an issue for some of like the researchers there. Although I know you have partnerships with Facebook, so maybe it's like less of an issue. The other thing is just like either like lack of like availability of code or errors in the code. You know, it's often like you see papers released and published where they say like the source code is coming, or links to like an empty GitHub repository. I mean, if you can't run the same code as the authors, you don't stand a chance of being able to reproduce the results, or rather you can try, but it'll be a lot more work. Yeah, a bunch of other things and like related to like reproducibility that we need to address would be like the underspecification of metrics, and so just not being like clear enough and like the metrics we're using, and also possibly, you know, what exactly test set was trained on, and, you know, making sure that stating that, you know, the test set wasn't used as part of like model training, because it's sometimes we kind of see that, which isn't great. Yeah, and then there's I'll move on. There's like obviously like a bunch of other like issues within reproducibility, and you're probably as experienced or more experienced than me in trying to tackle some of these. And so we just wanted to take a quick poll. I'm just curious if people want to drop in the chat. Like, have you tried and failed to reproduce an experiment? And so like I know for myself, I have taken code from papers that have just been published and tried to like replicate some of the results, so even just like running some of the inference on it, and especially, you know, say if it's you know, like a visually interesting like a GAN model, or it does something like interesting with like computer vision. Often the images that are like displayed in the paper are like kind of quite different to the images that you actually see in your own kind of like playing around with the model. And so there's like an element of like reproducibility there for sure. And cool, yeah, we have like a few yeses. Pascal also, even just this morning, tried and failed to reproduce an experiment. So yeah, this is a real thing that like people kind of struggle with every day when they're training ML models. Cool, thanks for dropping that in the chat, guys. And so this is from an article in Nature in 2016, where they did a survey across a whole range of fields in terms of like asking like if folks have tried and failed to reproduce an experiment. And you can see on the left, we've like across chemistry, biology, physics, medicine, earth and environment, like there's like very high percentages across all fields of people struggling to reproduce someone else's work, but even their own work, which is like super interesting, because you'd expect that they would have kept like good notes and would have like kept it like and be able to like know exactly how to reproduce their work. But even with their own work, they struggle because obviously, or maybe there's like a lack of documentation or something like that. And so on the right, you can see some of the factors that contributed to this lack of reproducibility. And like one of that, often cited ones is pressure to publish. And, we see this a lot in the machine learning community as well. And I'm sure you feel this pain like a few times a year, the pressure to publish and or to make a submission before a conference deadline is quite intense. And so that can lead to possibly skipping out on documenting like exactly what you did to get the results that you did, and then like a bunch of other like issues there as well. Obviously, like there are always issues around like low statistical power and like poor analysis, and yeah, like other relevant ones for machine learning. Again, like the code being unavailable, and trying to replicate someone's model based on a description, a couple of lines description in a paper, and trying to guess, what epsilon value they used in like their layer norm or something like crazy like that, that can sometimes make a difference. And so there is this issue, and we're not alone in the world of like deep learning for sure. Another quick question for folks who want to drop like a quick answer in your chat. Do you have a process to make your models reproducible? So for your own work, like are you tracking results? Are you using a tool like weights and biases or MLflow or something similar? Are you jotting things down in a text file, in CSVs, in Google Sheets? Like one thing we see within weights and biases when it comes to tracking your results is that our biggest competitor is actually Microsoft Excel, in terms of that's actually where most people, be they students, be they like researchers, be they like in large like established companies that do a lot of ML, still rely on spreadsheets and manual data entry for a lot of their tracking. And so it's a bit of the Wild West when it comes to reproducibility. And so Pasquale says, versioning continuous integration to check if changes to the code alter previous results, and more recently weights and biases to monitor training dynamics. Good to hear you've got some like versioning and continuous integration for sharing your code, and obviously like happy days you're using weights and biases as well. Cool, thanks Pasquale. And we have another also no for making your model reproducible. So hopefully by the end of this talk, we might have a stronger idea and impulse to do some tracking, and hopefully we can make it as easy as possible in the process. Cool. And so this is the answer to the results from like the same article in Nature to that question. And so you can see there, like, yeah, 34% of folks didn't have a process to make the work reproducible, which is a pity for sure. And also, when asked, is there a reproducibility crisis in their fields, 52% said there is. And so it's kind of like widely acknowledged. But I think something that like isn't getting enough attention as it deserves. And probably, and there's like obviously multiple reasons for that. Incentives in industry and academia to like move on to the next thing versus documenting and trying to reproduce older work.
Is this for science in general?
Yes, this is related to that Nature paper, which is like science in general.
Okay, because I sort of think of reproducibility as meaning different things in science and computer science. So in psychology, for example, I would say it's not reproducible if the hypothesis was just false and you got significant data by chance. Whereas in computer science, it seems quite a different thing. Like you could have chance results if you're overfitting some data, but you could also have just poor documentation that's not reproducible even on the same data.
Cool. Yeah, exactly. Yeah, yeah. Like that's a great point and like a great distinction to make for sure. Great. Thanks, Ruben. Cool. And so maybe we can learn a few good habits today. So there was this nice quote: "Reproducibility is like brushing your teeth. Once you learn it, it becomes a habit." And so it really is one of those small little changes to your workflow that can have like long or like large impacts and positive impacts downstream in your work that can compound over like, you know, weeks and months of years of work. Cool. So what does it mean to be reproducible? And so there was this great checklist from Joel Pinot at Europe's. You might be familiar with this already, where they actually ran through a big list of things to make sure you're doing to ensure that you have like model reproducibility. And we won't run through this whole list here, but if you search for Joel Pinot and Europe, so and this checklist, you'll probably find it online. It's a super valuable list, and kind of really kind of like covers all your bases in terms of like you know, from the paper point of view, like the claims you're making, to like the data sets you use, to the like algorithms you're using, and also like the actual like code that you're sharing, training code, dependencies, if you're using pre-trained models. Yeah, just like a really thorough list. And so, you know, if you take all of the boxes here, I think it's like fairly safe to say that your work should hopefully be quite reproducible. One thing that's not here, and I guess a little bit more recent, would be the model cards that you're seeing pop up more and more again. And so when we're like releasing a model, you know, it's always good to release as much data with that model as well. And there's again a lot of overlap between model cards and some of the data that you would have here in terms of obviously like the training that data that model was trained on, and the results of that model, code to train it, etc., etc. But yeah, so that's a great checklist to run through for sure. Cool. So what I'd like to show you now is how weights and biases can help you know, kind of better understand your models, and through being able to reproduce them. So to give you kind of some context and kind of to kind of locate us like where we are in the like wide world of like machine learning and deep learning. This is on the top row. You see, it's a kind of like a fairly typical stack for software engineers today. Obviously, there's like a way more tools they use, but there's a flavor of some of the tools they use for like the different stages when building like a traditional software product. But there isn't the same stack of tools yet in the machine learning and deep learning world. And so you see, if you were to like kind of break up the ML you know, workflow or like life cycle of like a model into its different stages, you have a lot of custom solutions, files and like random drives and like storage buckets, text files to like manage your model pipelines, you know, screenshots and CSVs, and 101 different Jupyter notebooks for all of the different experiments you've tried. You know, model CI/CD is when it comes to like deploying your models, it can be a bit of the Wild West, and so there's a lot of custom scripts there and a lot of duplication of work, people doing the same thing. And then production monitoring solutions are starting to emerge, but again, there's no clear definitions on what constitutes like the right way to do production monitoring. And so the idea with weights and biases is that we aim to cover the entire like life cycle or like workflow of your machine learning. And so the product started in in terms of like experiment tracking, in which you can see in the model there. But we also now have features that let you version your data, let you visualize your data, optimize models with our hyperparameter optimization tool called Sweeps, and then like share your results, kind of like quick analysis or kind of longer, like more polished results with our reports tool. And so weights and biases is just a couple of lines of code, and that you'll see in a second, and it works with all of the major like ML libraries that you use today, all of the main like frameworks you use today, like PyTorch, Keras, like JAX, you can see like TensorFlow and more. And we have a bunch of integrations into the most like popular open source deep learning libraries, as well as like a long tail of like smaller ones as well. So this might give you a flavor of what your work looks like before before kind of getting into grips with experiment tracking, however you might do it. And so you might be pulling like data from like your console logs, hopefully at least it's logged to a text file somewhere at the minimum. But it can be a bit of a fragile journey to take your results from your model training all the way through to your like the finalized and published paper that you can see on the right. And so weights and biases hopes to basically make that journey a little bit more reliable and reproducible. And so this is an example of what our weights and biases dashboard looks like. I'm going to run through a few more in a second, so I can skip on here. But basically you can see a whole bunch of experiments listed on the left, and a chart with all these like beautiful purple and yellow lines, which I'll get into shortly. Super quickly, this is what it looks like to add weights and biases to your code. And so after we install the library, we initialize what we call a weights and biases run, which is initialized with wandb.init. To that, you can then add some like configs if you need. Always a good idea to log as many of these as possible, because you never know which one you might want to like play around with or like add in the appendix of your paper in the future. And then as you're training and you want to log your metrics, it's just a simple call to wandb.log. You pass it a dictionary with the name of your metric and the value, and you just call .log as often as you need during training, and then you'll have a lot of nice looking dashboards at the end of the day, hopefully. So I have a bunch more slides there, but I actually just want to show you a few weights and biases dashboards, if that sounds good. But before I do, I can pause if anyone has any questions at this point, or any thoughts you'd like to share about reproducibility in general. No, I think we're good. Cool. So this is what it looks like to have a kind of mature workspace in weights and biases. And so the workspace here supports a whole bunch of different chart and panel types, as we'd like to call them. And so you can add markdown panels if you want to give any specific information or like pointers about what's going on in this workplace to like your colleagues or like people you might be sharing it with. We have these like larger KPI panels that can like show either like the min or max of like different values. So you can have like keep an eye on like one single number, especially if you're doing a lot of training, to see, okay, this is like this is the value for my like the best model in terms of like all the models that I'm currently training. We have all of our good old loss curves, and yeah, I think they're pretty straightforward. They support visualizing like kind of as many runs as you need, although they start to show just in the first 10 runs after when you start to like log a lot of things. You have a bunch of other inbuilt charts as well, like block charts, feature importance charts, a whole bunch of others. The other thing I should say is if you don't want to use these inbuilt charts for weights and biases, you can also directly log your matplotlib charts directly to weights and biases, and then just like have them there associated with the particular run that generated them for that like reproducibility element. We also have this nice run compare plot, and so this is quite nice because it lets you quickly see the differences in the configuration and the setup and the results between all of your different models selected. And so here you can see I've got this like diff only toggle on, and so here very quickly you can see in this case I was playing around with the gamma of this model, and you can see the different values for that were used, also the different like learning rates across some of these models, the different like min child rates. So again, it's a really easy one. If you see two models that might be have like widely different performance, you can quickly see the difference in these values for those. We also track system metrics when you run weights and biases, and so you don't need to do any additional logging or like adding any more code to get these. Once you start weights and biases run, we'll start logging the performance of your GPU. You can see like disk utilization, kind of memory usage, like in a whole bunch of system use metrics that can be useful, especially when you're training really large models, and you might constantly be bumping up against the limits of your GPU memory, or vice versa. You might have a lot of GPU memory that you're not using, and like charts like this will quickly show you that maybe you can like increase that batch size another bit. One last thing to show you here, and so this is after like pushing away that workspace. This is where the all of our like configs are logged, and so here I've got a bunch of columns that are pinned. Right, that's why I had to zoom out a little bit. But here, if we scroll to the right, you can see everything I've logged for each one of these experiments. And so like, this is like down to basically like every setting that was used in this model to like ensure that there's like full reproducibility here. If you want to go into a particular model and just zoom in on that one for a sec, we get the same charts that we just saw, but just for that individual model. We can go up here in the top left and see actually a little bit more info than we could in like the aggregate page. And so here, for example, we can see the OS that this was trained on, like the Python version. I have code saving turned on for this, and so Weights and Biases has this feature called code saving, which is in your settings, which is turned off by default. But if you turn it on, it'll also log the script or the notebook where Weights and Biases was called, and so that adds like another layer of reproducibility. As you can see here, this is the Colab or the notebook, which is running Colab, that I used to train this model. And so like all of the code that generated this run is there for me. Here, if we scroll down, again, another view of like the same kind of configs we saw on the main page. And you can, quickly like search these and like find the specific configs that were used for that, as well as all of the like summary metrics that you care about for your particular model. We also track we have this feature called artifacts, which is essentially used for like a data set and model versioning. And so we track, if you want to track it, we can track what artifacts you were used as like inputs into your training run, and in that case, obviously, it's usually training data, and maybe if it's a pre-trained model, also like the pre-trained model weights, if you want to save it into weights and biases. And we also track the outputs, which could be your trained model, and maybe you want to also log the predictions, for example. Great. Does anyone have any questions on that? I'm happy to keep going. Cool. And so if we coming back to here for a second, we've run a bunch of experiments we're kind of like getting a feel of, you know, under what conditions our models seem to be training well. You know, we've kind of like identified like some promising avenues to explore, but now we maybe want to like really kind of turn up the dial in terms of like performance for this model. And so you might want to use weights and biases sweeps and start doing like some hyperparameter sweeps. And so we have our own sweeps algorithm. We have a Bayesian algorithm that'll do Bayesian hyperparameter optimization. Obviously, you can like do random or grid search as well if you like. We also have callbacks and integrations with Optuna and Raytune. And so if you prefer to use some of their algorithms, which can like are a little bit more advanced, you can use them, but still log the results back to your weights and biases. So you get the best of both worlds. And so, for example, this is Crazy Plot is an example of a whole bunch of sweeps I ran, where each, I'll zoom in a little bit, hopefully you can see it better, where each of the kind of like vertical axis you see cutting through it are the different hyperparameters I was playing around with. And so looking at this first, it all looks like a bit of a mess. It's hard to identify, you know, what parameters were actually the ones or the ranges that I should care about. So we can do a nice filtering over here. We take this. And now we fade out all the other runs, apart from the runs that had the highest validation AUC score. And now very quickly you can see, okay, the ranges for each of these hyperparameters. And so, for example, you know, you can see learning rates between 0.8 and 0.85 look pretty decent. Gammas, you know, again, between 0.5 and 0.7, where other hyperparameters, like, for example, the like early stopping round, or maybe even min child weight, are kind of less sensitive to the like ranges you can like set for those. And so this tool can be super helpful to you know, to identify these. And you know, potentially you know, what we see people do sometimes is they maybe like run a few sweeps, or like they like run a few random sweeps like this. They kind of identify like the rough ranges that could be like promising, and then they actually run another sweep with like a bit of more like of a clever algorithm. It could be like the Bayesian ones or others, but you know, limiting it to these like narrower ranges, and then that kind of like you know, bootstraps that algorithm a little bit and kind of gives it a little nudge in the right direction by like limiting it to slightly narrower ranges than you might do use otherwise. And so that's like one nice feature or nice approach you can take with doing your hyperparameter searches. Happy to answer any questions if people want to answer or drop anything in the chat. But otherwise I can keep going. And so we'll say, okay, now we have a decent idea of the or like rather say for example you want to like share these results. That would probably be a good direction to take. So you want to share this with your supervisor, for example, and so you can quickly drop this into a report like so. Sorry, that took a second. And so straight away you can like bring these charts into these like reports that we have with weights and biases, and we can say my hyperparameter optimization results, and then you say for example, we can say here, look at my chart, and so you can say, for example, like these parameters look good, L over 0.82. That's a little and so you can give a little bit more context around the chart you're sharing. And this could be, you know, just a quick short note. You hit save there. Quick short note that you want to like save to and share with like your supervisor, a colleague, a friend. You know, throw it into the link into like Slack or email or Teams or whatever you're using. And then like you can get like, and then if they have a weights and biases account. They can also like add comments to the either to the bottom of the chart or else to the actual like each chart itself. And so you can say, yeah, those ranges look great. And then you can you know, quickly get some like feedback on your results, because that's probably the whole point that you're sharing it with them. So that's a quick flavor of how you can like then like share your work. Obviously, people also use reports for more like longer like published features, and so like it supports, you know, all of the main functionality you'd expect from like a decent Word editor, and you can embed images, videos, GIFs, tweets, whatever you like, code blocks, obviously, to make like these like nice, really rich like stories about your work. The last thing I would like to show you quickly, and then we can pause, is our tool called Tables. And so we've say now we're going on our journey. We have you know, done some initial training. We have now kind of really dove in and done some hyperparameter optimization and like really found a set of hyperparameters that give us a great model. And now we would like to maybe like explore and evaluate that model and its predictions. And so we have a tool called Tables, where you can like explore data, you know, explore your like data sets, and that can also include like evaluation data sets. And so this is another project, but let's pretend for now it's the same one. And so here's an example of weights and biases tables. And I'm just going to make this full screen so you can see this a little better. And so what tables basically are is you can consider them like basically a data frame that supports, or a spreadsheet that supports, you know, rich media. And that could be images, that could be video, audio clips, GIFs, you know, 3D like molecule visualizations, point clouds, you know, pretty much whatever you might want to be experimenting on. Tables can support that visualization alongside, you know, your text and you know, float and like integer data as well. So it makes exploration quite quick and easy. So here we are looking at the results on our evaluation set. We're trying to predict the class of like animal or like organism here. And so we have like, we've logged the model scores for each one of the classes that we have, as well as the guess, which, you know, is just like the class with the highest score. And so one thing you might want to do quickly is to like group by all of your guesses. And so this is now grouped by, and we can make this column a little bigger. This is now grouped by all of the rows in your data set where the model has guessed, you know, this class over here. And so like kind of quickly scrolling through some of these, you can get an idea of like, okay, how well is the model doing in terms of like guessing that these are like reptiles or not. Sometimes you see in this reptile guess class that you can actually see frogs and like confusion there over amphibia. You can also see for this guess the actual distribution of scores across each one of these. And so like kind of like you'd hope, the most of the scores are quite low, and you know, like mostly the vast majority are like 0 or close to 0, apart from the scores for reptilia, which are all like 1 or like quite high. And so there's a nice kind of distribution here with not too much confusion in the middle for some of these like other classes. We can reset this table, and so that's, you know, one way to browse, but it's not super efficient, and you might miss some interesting things. So we can go a little deeper and actually add a new column here. And so this column is going to basically tell us a Boolean column, and it's going to show us whether the model prediction was correct or not. And so how we do that is we say, okay, like find us or give us when the guess is not equal to the truth. There it is. And we can call this and say incorrect guess. And so straight away, you can see here panels identifies the likely kind of data type for the column you're about to create. And so it's correct. We wanted a Boolean, so we won't change that. And we can just click away. And now we have our column here. And this is showing us the times when the model was incorrect. And you can actually verify that here with your labels if you like. And now we want to maybe look a little closer at our say what we would like to do. Yeah, let's look at our amphibia class and understand how our predictions are looking for that. So we're going to filter by the truth column, and we can say truths equals amphibia. There we go. We can hit apply there. And so now our table is filtered just to the images with amphibians. And then we can then group by whether or not those predictions were correct or not, and start to get a better understanding of our predictions and how our model is doing. And so, yeah, we might want to check out some of these images, for example. And interesting, yeah. And so you can see, okay, in the cases when your prediction was this will be correct. Yeah, we see lots of frogs. This looks great. Or when your prediction was incorrect, we actually see, the model is getting confused between amphibians, and this looks like a lizard. And these, yeah, we actually have some amphibians there. So I don't know if some of these data might be mislabeled. But again, for these this grouping, you can again get a distribution of your scores for each of the model outputs. And so it gives you just quite a rich way to kind of dive deeper into your model evaluations, especially when you're dealing with rich media, like images, like video. And it can be a little slower, cumbersome to parse hundreds and thousands and tens of thousands of predictions to understand how your model is doing. So I'm just conscious of time. We're at 2:50. I'm going to stop talking. Would love to hear if anyone has any thoughts, questions, concerns about reproducibility in deep learning. Would love to hear other ways of how you're dealing with tracking your work and dealing with reproducibility. Or if you have any questions about weights and biases, would love to hear too. There's one question in the chat from Augustine. Are there, related to weights and biases, is there any plans to make the plots more flexible in reports? For example, change the font size. I'd love to take results from reports and put them into papers, but found this difficult. Yeah, definitely. So we do see this, and it's it is something on our radar, especially with folks who are using weights and biases and then looking to add their plots to reports. It is on our engineering team's radar that we would like to offer different stylizations of plots so they can be easily exported for papers and for publication, without having to download the data and maybe reproduce in Matplotlib like some people kind of have to do today, but can't give any firm date on when that feature is going to happen. But 100% we're aware of it. And thanks, Augustine, for the question.
Does anybody else have any questions? I guess not. Morgan?
No, yeah. I think we could probably wrap it up there.
Yeah, that was brilliant. Thank you very much for coming and sharing. Okay, then. I mean, I don't see any questions in YouTube site also. But thank you so much, Morgan. It was nice having you.
Great, yeah, I really appreciate it. And wish everyone there at UCL the best of luck at tracking and reproducing their work.
All right, then.
Great.
Thank you very much, Morgan. Thanks a
Thanks
lot.
all. See ya.
Bye.
Bye.
See you. Bye.